There are construction projects that change the face of a city. There are those that change the face of a country. And there is a special category of projects that change the face of reality itself. Not because they are incredibly beautiful or technically perfect, although both are often true, but because the very fact of their existence forces a rethink of what people are capable of doing if given enough time, money, and stubbornness. Right now, as you read this, construction sites of such a scale are underway on several continents simultaneously that they are difficult to imagine even from photographs. Thousands of workers, hundreds of cranes, billions of dollars a month, deadlines that are pushed back, budgets that grow, and ambitions that do not diminish. Each of these projects is a bet on a future that has not yet arrived. The bet is expensive and not always a winning one, but that is exactly why they are so interesting to watch. Let's start with what has already changed the very idea of what a city can be. In the desert in the northwest of Saudi Arabia, something is being built for which there is no suitable word in the architectural lexicon yet. The official name is NEOM, and its composition includes a project called The Line. 2 parallel walls 500 meters high, 200 meters wide, and 170 kilometers long. A linear city without streets, without cars, without carbon emissions. It is assumed that 9 million people will live in it in a vertical city that will stretch across the desert, mountains, and the Red Sea coast like a giant mirror monolith. The idea looks fantastic, in both a good and a bad sense of the word. Inside the 2 walls, the entire city infrastructure should be located. Residential quarters, offices, parks, stadiums, farms, factories. Transport is only underground. High-speed capsules that will cross the entire city from end to end in 20 minutes. Outside, the walls will be covered with mirror panels reflecting the desert and the sky. The project is conceived as an answer to the question of what the city of the future should be, in which cars are not needed, emissions are not needed, and spreading out to the sides for hundreds of kilometers is not needed. Critics, and there are many of them, and among them are many serious urbanists and engineers, point to fundamental problems. 9 million people living in a 200-meter corridor mean a density comparable to the most overcrowded areas of Hong Kong, multiplied by 170 kilometers of length. How will natural ventilation work in a closed space of such a scale? What will happen to the psychological comfort of residents who have either another wall 200 meters away or the desert out the window? How to evacuate millions of people in case of an emergency from a structure that essentially has only 2 ends? There are no official answers to these questions yet, but something important is lost behind the criticism of the architectural concept. NEOM as a whole is not only the line. The project includes several more components, each of which is unprecedented in itself. Sindala is a resort island in the Red Sea, which is being built from scratch and should receive the first tourists in the coming years. Oxagon is a floating industrial port in the shape of an octagon, which is planned to be erected directly in the sea. Trojena is a ski resort in the mountains of the Saudi desert, where in winter the temperature drops enough for artificial and, possibly, natural snow. It is planned that in 2029, the Winter Asian Games will be held here, the first in history held in a Middle Eastern country. All this set of objects is intended to turn the sparsely populated northwestern corner of Saudi Arabia into one of the key global centers of tourism, technology, and highly qualified labor. Whether it will work or not is an open question, but real money has been invested, and the land has already been dug up. Construction is underway. The scale of preparatory work in the desert, huge excavations of soil, access roads, and labor camps are visible on satellite images. The initial completion dates have already been shifted several times, and ambitions have been revised downwards. The first realized section, according to the latest data, will be significantly more modest than initially stated. But the project itself is not closed. Saudi Arabia has invested not only money in it, but also its reputation. And this means that something will eventually appear in the desert. What exactly this something will turn out to be is a separate question. At the other end of the world, in India, a project is unfolding that should prove that the world's largest democracy is capable of building infrastructure at a speed comparable to authoritarian regimes. A high-speed railway between Mumbai and Ahmedabad is 508 kilometers of track, which a high-speed train should cover in approximately 20 minutes, less than a regular express goes now. It has been under construction since 2017, with Japanese technological and financial participation. Japan provided a loan in the amount of about $12 billion on exceptionally favorable terms. Shinkansen E5 series trains will reach speeds of up to 320 kilometers per hour. Construction is proving more difficult than planned. The issue of land alienation, buyout, and forced seizure of plots from thousands of landowners and tenants along the route turned out to be politically much more painful than the designers expected. Part of the route passes through densely populated areas, where compromise with each landowner is a separate story. Deadlines have been shifted several times, but construction continues, and the first section of the line, according to the latest data, should open for passengers in the coming years. For a country that has long been associated with overcrowded and chronically late trains, this will be a qualitative shift. At the other end of the world, in Egypt, they are building a new capital, not expanding the old one, not moving government quarters to the outskirts. They are building it precisely from scratch, in the desert 45 kilometers east of Cairo. The project is called the New Administrative Capital, and for all the modesty of its name, it represents one of the largest urban planning experiments in history. The area of the new city is about 700 square kilometers. This is more than the area of Singapore. The planned population is 6 to 7 million people. The idea of moving the capital away from congested Cairo has been discussed in Egypt for more than 1 decade. Cairo is one of the largest cities in the world with a population of about 20 million people. It suffers from catastrophic traffic jams, housing shortages, crumbling infrastructure, and periodic floods. The new capital is conceived as a clean slate. Wide avenues, modern traffic management systems, digital infrastructure from the very beginning, rather than built on top of century-old communications. Construction began in 2015 and proceeds with varying intensity. Government buildings, the presidential palace, parliament, military headquarters, all this has already been erected or is almost completed. Some officials have already been transferred to the new workplace, but residential quarters are filling up more slowly than planned. Infrastructure outpaces demand, and the city itself still looks like a set for a movie about a future in which there are no people yet. Experts in the field of urbanism have long described the disease that many capitals built from scratch suffer from Brasilia to Astana. It is easier to design a city than to fill it with life. Life does not move by order. Nevertheless, the scale of what has already been done is impressive. The central business zone of the new city includes the tallest skyscraper in Africa, more than 400 meters. The new international airport is designed for tens of millions of passengers. A high-speed railway line will connect the new capital with Cairo. This is not a paper project and not an abandoned construction site. This is a real city that exists physically, but does not yet quite exist socially. If the 2 previous projects are a story about an attempt to build the future from scratch, then the next one is a story about how to connect what nature has divided. Istanbul is already one of the few cities in the world divided between 2 continents. The Bosphorus Strait, connecting the Black and Marmara Seas, divides the city into European and Asian parts, and the existing 2 suspension bridges and 1 road tunnel under the strait are working at the limit of their capacity. But Turkey has conceived something fundamentally different. Canal Istanbul is an artificial waterway 45 kilometers long that will run parallel to the Bosphorus through the European part of Turkish territory. Essentially, it is a second Bosphorus created by human hands. A canal 250 meters wide and 25 meters deep should ensure the passage of large tankers and container ships bypassing the overcrowded natural strait. Along the banks of the new canal, it is planned to build new residential quarters, business districts, and tourist infrastructure. In fact, it is a project for a new city along an artificial river. The cost of the project is estimated at $75 billion. Environmentalists are sounding the alarm. The canal will pass through a reservoir that supplies drinking water to part of Istanbul, destroy several ecosystems, and may change the hydrological balance of the Black Sea. Geopoliticians point out that the new canal will take Turkey out of the scope of the Montreux Convention of 1936, which limits the passage of warships through the Bosphorus. This means that through the new canal, naval vessels will be able to pass without those restrictions that are currently in force. Construction was suspended and resumed several times, deadlines were shifted, but the idea was not abandoned. In Asia, perhaps the largest infrastructure program in human history is unfolding: the Chinese Belt and Road Initiative. Speaking of it as a single project is incorrect. These are thousands of individual projects united by a common logic: to create a network of roads, railways, ports, pipelines, and digital infrastructure that will connect China with Europe, Africa, and South Asia. The total volume of investments within this initiative, according to various estimates, is from $1 to $8 trillion, depending on what exactly is considered part of the program. Among the specific projects underway right now is the construction of a high-speed railway line between Laos and China, already launched into commercial operation. The port of Gwadar in Pakistan, which should become a gateway for Chinese exports to the Arabian Sea. Railways in Kenya connecting Nairobi with the port of Mombasa, and several large energy facilities in Bangladesh, Myanmar, and Ethiopia. Critics of the program, and there are many of them, talk about a debt trap. Countries receiving Chinese investment accumulate debts that are then used as a tool of political pressure. Supporters object that without these investments, the infrastructure gap between rich and poor countries would be even more catastrophic. The dispute continues, as does the construction. Let's return to Europe, because here too there is a mega project that is little talked about outside specialized publications, although its significance is difficult to overestimate. Under Geneva, at a depth of up to 100 meters, the largest scientific machine in human history has been operating for several decades, the Large Hadron Collider. But the European Organization for Nuclear Research, CERN, has already developed a concept for its successor. The future circular collider will have a circumference of 100 kilometers, almost 4 times larger than the current one. Its construction is estimated at approximately 20 billion euros, and full commissioning is planned for the 2070s. This is not a fantasy and not a preliminary idea. This is an approved concept with detailed technical documentation, ongoing geological surveys, and international negotiations on financing. What makes this project a mega-project of a special kind? The fact that its result, by definition, is impossible to predict. The Large Hadron Collider was built, among other things, for the search for the Higgs boson, and it founded in 2012, confirming the standard model of particle physics. The future collider is being built for questions, the answers to which may again overturn our understanding of the fundamental laws of nature, or not overturn it, which will also be an important result. This is an investment not in a specific product, but in the opportunity to ask the right question and hear the answer of the universe. There are projects that are built because without them one cannot survive. It is to this category that the largest projects in history for protection against water belong. Venice is sinking. This is not a metaphor. It is a literal geological reality. The city, built on wooden piles in a lagoon, is slowly sinking while the level of the Adriatic Sea is slowly rising. In November 2019, a flood covered 87% of the city's territory, one of the worst indicators in the history of observations. the MOSE system of mobile dams, the construction of which began back in 2003 and the cost of which has long exceeded 8 billion euros. After many years of delays, corruption scandals, and technical problems, has finally started working. 78 metal shields installed at the bottom of the 3 inlets to the lagoon can rise, blocking the access of seawater in case of a threat of flooding. The results of the first years of the system's operation turned out to be encouraging. Several potentially destructive floods were prevented, but engineers honestly admit that MOSE is a gain of time, not a final solution. At current rates of sea level rise, the system will cope for several decades. What will happen next? A question for which humanity does not yet have a ready answer. A similar story is unfolding in the Netherlands, where the Delta program for coastal protection against floods has been implemented for several decades and, in light of climate change, is constantly being expanded and refined. The Maaslandkering storm surge barrier near Rotterdam, 2 steel arms of a giant, each weighing 30,000 tons, which close when a storm threatens, blocking the entrance to the Rhine Delta, is one of the largest mobile engineering structures in the world. It has been operating since 1997, but its technical maintenance and adaptation to new climatic conditions continue continuously. Among the projects that change not the face of a city and not the fate of a country, but potentially the fate of the entire civilization, the construction of ITER, the International Thermonuclear Experimental Reactor in Cadarache, France, stands apart. This is an attempt to prove that controlled thermonuclear fusion, the very process that occurs inside the sun, can be reproduced in terrestrial conditions and used to generate electricity. If this works, humanity will receive a practically unlimited source of clean energy. Hydrogen, the most common element in the universe, will become the fuel, and the reaction product will be helium, which is absolutely harmless. No carbon dioxide emissions, no radioactive waste in significant quantities, no dependence on oil and gas. ITER has been under construction since 2013 with the participation of 30 countries, including Russia, the United States, China, the European Union, Japan, South Korea, and India. This is unprecedented in itself. The project survived several serious geopolitical crises, sanctions, and the severance of diplomatic relations in a number of areas. No international cooperation did not stop. When scientists and engineers from countries whose governments barely speak to each other continue to jointly mount magnetic coils weighing several hundred tons in an underground hall under Provence, this in itself is a kind of mega-project, only in the field of human relations. The central magnet of the reactor, the most powerful superconducting electromagnet in human history, has already been assembled and tested. Its field is so strong that it is capable of lifting an aircraft carrier. It is this field that will hold plasma at a temperature of 150 million degrees, 10 times hotter than the core of the sun, inside a toroidal chamber, preventing it from touching the walls and destroying them. The very idea that such a design could work at all seemed theoretically possible, but practically fantastic to physicists 20 years ago. The cost of construction has already exceeded 20 billion euros and continues to grow. Deadlines have been repeatedly shifted. The first plasma discharge was planned for 2025, then moved to later dates. Full power, the so-called DT mode, in which the reactor should produce 10 times more energy than it consumes, according to the latest forecasts, will be reached in the years 2035 to 2039. Critics have long and not without reason joked that controlled thermonuclear fusion will always be 30 years away from practical realization, and that this distance does not shrink no matter how many years pass. This joke has been going around among physicists for several decades, but in recent years, something has changed. Several private companies, Commonwealth Fusion Systems, TAE Technologies, Helion Energy, have announced significant technological breakthroughs in creating compact thermonuclear reactors and have attracted billions of dollars in private investment. If even one of these projects fulfills its promises, the 30-year joke will prove irrelevant sooner than it seemed. There is a category of megaprojects that usually remain in the shadow of more glamorous cities of the future and thermonuclear reactors, but which in reality affect the lives of more people than any of the ones listed above. These are large hydroelectric and water management structures. The Grand Ethiopian Renaissance Dam on the Blue Nile River is the largest hydroelectric power plant in Africa, the construction of which is being completed in Ethiopia. It is simultaneously an engineering achievement and a geopolitical time bomb. A dam, 145 meters high and almost 2 kilometers long, blocks the main tributary of the Nile, giving Ethiopia the opportunity to generate about 6,000 megawatts of electricity, almost as much as the entire country consumes today. For a state in which more than half of the population still does not have reliable access to electricity, this is a transforming project. The problem is that the Nile flows not only through Ethiopia. Egypt, a country with a population of more than 100 million people, 90% of whom live in a narrow strip along the Nile, receives 90% of its fresh water precisely from this river. Sudan is located between the two countries and has its own interests and fears. Negotiations on the rules for filling the dam's reservoir drag on for years without a final result. Ethiopia fills the reservoir gradually, regardless of Egyptian protests. Egypt has repeatedly made it clear that it does not rule out military options for responding if it considers the threat to its water supply serious enough. The dam on the river has become a focus of tension between the three states, which has no simple solution. This makes it one of the few mega-projects in history around which the question of war and peace is literally being decided. Not in a metaphorical, but in a completely literal sense. All these projects share one trait that is not always obvious when looking at budget figures and completion dates. Each of them is a bet on a certain future. The line makes a bet on the fact that people will want to live in a vertical linear city without cars. The new administrative capital of Egypt makes a bet on the fact that officials and entrepreneurs will want to move from familiar Cairo. Canal Istanbul makes a bet on the fact that international shipping will continue to grow. ITER makes a bet on the fact that thermonuclear fusion is generally manageable on an industrial scale. The bets may not pay off. The history of mega-projects knows many expensive failures. Ghost towns, unfinished bridges, tunnels that turned out to be needed by no one. The famous mega-project syndrome, described by Danish economist Bent Flyvbjerg after analyzing hundreds of large construction projects around the world, sounds disappointing. 9 out of 10 mega-projects go beyond the initial budget. An overrun of 50% is the norm. An overrun of 100% or more is not rare at all. Deadlines shift almost always. The declared benefit often turns out to be exaggerated. This is not an accident and not the incompetence of specific contractors. This is a systemic pattern related to how people evaluate long-term complex projects at the planning stage. And yet the world builds. It builds despite overruns, despite shifted deadlines, despite scandals and failures. Because the Suez Canal, which was opened in 1869 after 10 years of construction and colossal human losses, changed world trade forever. Because the Channel Tunnel, which critics called an unrealizable dream, today annually carries more than 20 million passengers. Because the Panama Canal, the construction of which was accompanied by the disaster of the French attempt and required an American engineering revolution, became one of the axes of world logistics. The history of megaprojects knows another side. Bridges that seemed like madness before construction and became symbols of their cities. Canals that changed world trade. Reactors that gave electricity to millions. And this is the most important thing. Projects that we consider a matter of course today were once incredible too. City water pipes, electrical networks, railways, the internet. All this in its time looked just as fantastic, or even more fantastic, as a linear city in the Saudi desert, or a thermonuclear reactor in Cataract, France, looks today. The people who built the first power plants did not know if there would be a demand for their electricity. The people who laid the first railways heard from experts that locomotives would never be able to move faster than a horse. And all this eventually became the foundation on which the modern world stands. Each of the current incredible megaprojects is someone's bet that in 50 years their result will also seem like a matter of course. Some of these bets will lose, some will win, and it is precisely the winners that will change how future generations live. Building the incredible is always a risk,